What's up, y'all? I know you're tired of my videos, but I don't really care. I'm going to do a mention of this in class, but this is more of a deep dive for those of you who are really using the virtual option, which is the simulator here, because someone brought to my attention that some of the data doesn't match or doesn't look like what it should look like. And so I did a little bit more of a deep dive, and I have some data here to kind of show the example. The simulation works really well for parts one, where you're looking at the changing hanging mass and the changing mass of the cart. And you get nice normal trends with your acceleration and your time data, and you could of course graph that. But when you add your friction, things kind of get wonky for some reason, and I haven't yet figured out why. But if you use the accelerations that are given by the simulation, and I've left my trend line here so you can see all those different distances, you'll see that it ends up getting to the same distance, approximately 103-ish to 104, and the acceleration value that they give you down here actually doesn't match what it should be based on the calculated value. And so what I did is I took and found the net force by doing the hanging mass applied force minus the frictional force, and then divided by the total mass of the system. And that gave me these accelerations instead of this acceleration, which was given by the actual simulation just as a value in that corner. I think part of the problem is on the simulation. When you change the mass, either on the cart or on the hanging mass, it doesn't actually update right here the total mass of the system. And so I don't know if that's why it's giving you a incorrect value for the acceleration. But regardless of whatever the case may be, as long as you're looking at and you see the correct trend, then there's not really any problem here. One thing to note is even with the wrong acceleration values, the simulation does give you the correct time values and the correct distance values, which to me is very odd. But you'll see that I calculated the acceleration to get the correct value. Then I used kinematics to find what the distance and the time should be for each of the trials. And these values that are calculated here match the output values of the simulation, even though the acceleration values they're showing you are wrong. So I think it's something wrong with the coding of the simulation, or it's something that I'm missing here. But long story short, as long as you're looking at and you can notice the trends that adding friction makes it longer in terms of time to reach the end, then you're really getting the main idea. And of course, you can see that the acceleration does decrease even if it's the wrong values. But you can see that it really decreases more dramatically when you actually calculate the values and you do your applied force minus frictional force. So hopefully this is helpful. If you have trouble with the second simulation, I'll have that data to show as well when we talk in class on Wednesday. But hopefully this answers some questions if you were having trouble or seeing some things that looked wonky on simulation part two.